I like the way that they've broken this problem up into multiple steps so that if you answer each one completely, you'll get to the end without feeling overwhelmed. So essentially what we're doing here is deriving the golden ratio, but we're going to do it step by step and it's not going to be that complicated. It says for letter A, the line segment is divided into two segments, one of length A and one of longer length B. Write the ratio of the shorter segment to the longer segment. Well, there's an easy one. A to B. Okay, letter A done. Now write the ratio of the longer segment to the sum of the lengths of both segments. Okay, so for this first one, we're looking for the longer segment. Okay, so that's going to be B. B is the numerator. And what is our denominator? To the sum of the lengths of both segments. Well, that's just A plus B. Again, not very hard. Okay? The golden ratio is for values of A and B such that both ratios are equal to each other. Write this as an equation. Okay? So what they're saying is that the ratio that we wrote for this one and the ratio that we wrote for this one are equal to each other in the golden ratio. So let's write that down. It says write it as an equation. So we have A over B equals B over A plus B. B over A plus B. Okay? Be sure that as you're doing this, you're numbering each of these, you're answering each of these separately. And you're probably wanting to do this on a separate sheet of paper. No problem, no problem. Now it says multiply both sides by the expression B times the quantity A plus B. So I'm just going to do that on a separate sheet of paper. So right here we have A over B equals B over A plus B. Now we're multiplying it by the quantity B, and I'm going to change the color here. We're multiplying it by B times A plus B. Okay, I'll put it over 1 just to keep things straight here. So again, B times A plus B, all over 1. Okay, well, what you've learned about canceling is going to come in super handy here, because do you see that we can cancel the B's here? Here we can cancel the entire quantity A plus B. Notice that we're going to be left with A times the quantity A plus B, and we have equal to B squared. We multiply this out, we get A squared plus AB equals B squared. And that's the answer for letter D. Okay, so we have A squared plus AB equals B squared. All right? Be sure that you show that work somewhere on your paper. Now it says if A equals 1 and B equals x, find the roots of this quadratic equation using the quadratic formula. Okay, well that's interesting. So A equals 1, B equals x, and we're supposed to find the roots of the quadratic equation using the quadratic formula. So I'm going to insert another piece of paper, and I'm just replacing. So I've got A squared plus AB equals B squared. Now I'm substituting what they've told us. I'm saying 1 squared plus 1x, essentially, equals x squared. Well, that's a quadratic equation, people. So let's get it all set equal to 0. So that means I'm going to bring this stuff over here, right? Okay, so that leaves me with x squared minus x minus 1 equals 0. Hopefully you don't have any trouble following all of that. Now I've got the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know you can hear Pop the Weasel singing right now, can't you? Okay, so now I'm going to plug these values in. Here's negative b. Here's another negative b. This is a right here and c right here. And then in the denominator, we have a. So now let's just do the math on it. Well, this is equal to positive 1. plus or minus the square root of, I hope you can see that we are getting 5 under the radical. I guess my radical's a little bit big there for that little 5. Okay, so we have equals 1 plus or minus the square root of 5 all over 2. Okay, back to this. Let me just write the answer right here as well. So we have 1 plus or minus the square root of 5 over 2. Which root can you ignore? The negative 1. The negative 1, because you can't have a negative dimension. Okay, remember this is representing this dimension right here. You can't have a negative dimension, right? Okay, now all you have to do to the nearest thousandth, you have to calculate this value. And so just ignore the negative 1 and you should end up with 1.618. Obviously that's approximate, but it's to the nearest thousandths.